Huh? No, I was going to say it has to be really cheap.
Oh.
Yeah. Basically, internship. Yeah. Maybe hire is the wrong word.
Internship for
TA, exactly. Actually, yeah, TA hours I could have somebody sit there moving it around. That would be exciting. So 86?
You should
Right.
do 82 as well.
I should?
All the word problems.
Do all the work problems. Okay, alright, so here, you guys are gonna help me. Let's go ahead and just run through these. 82. So on 82, what kind of problem is that?
It's a distance
It's
time.
a word problem.
That's a good one, man.
Nice, just nice. Don't go out on a limb or anything. Like
Distance problem.
you didn't go back and say it's a math problem.
Distance.
Distance, rate, time, right?
Yeah, but it's a complicated one.
Well, it sounds kind of, it's got a lot of stuff going on. So see, Anthony leaves Kingston at 2 p.m., drives to Queensville. So much creativity there. 160 miles distant at 45 mile an hour. 15 minutes later, Helen, of course, is going the opposite direction. At what time do they pass each other on the road? So we got Kingston here, we got Queensville there. It's going this way. 45 mile an hour. What's up? 160 miles apart, right? At 2:50, so Helen leaves a little bit later, going a little bit slower. So they're probably going to leave. They're probably going to meet closer there. Whew. All right. So who's been on the road longer when they meet?
The first
Anthony.
guy.
Yeah, right. The dude. Who is it? Anthony and Helen. All right. So we got Anthony and Helen. Okay. All right. So you can still, since it's a distance rate time problem, you can see there's definitely two parts to it. There's two people. So we can still do distance equals rate times time. We got Anthony here. Call him Ant. We got Helen there. We'll call her Hel.
And hill.
Exactly, Ant Hill. Of course, the thing about the movie coming out soon. So. Yes. All right. So we could definitely put what where. There's no question about at least. Yeah.
Distance and the
Time
rate.
or the rate.
Careful, you can't do a damn thing with distance yet.
The rates.
Yeah, the rates I know for sure. Anthony's going 45. Ellen's going 40 mile per hour. Put an emphasis on that for some reason.
And then maybe an x plus 15 for the time.
All right, so
You should keep it in hours.
careful. Who's been on the road longer? And this might be where that emphasis on the hour. Why the hell did I say that? Why did I emphasize hour for some reason, right? So,
His would be T or A, whatever.
all right. So if Anthony's been on the road for X hours,
She's been on my
X minus
X minus 1.
X minus
1/4.
yeah, 15 minutes is how many hours?
1/4.
A fourth of an hour, right? So if you say X minus 15, then she's been on the road for 15 hours less. I think he made it to Queensville. He's been sitting around like, what the hell happened? I thought we were going to wave at each other as you went by. So this will be X minus 1/4. Because Helen's been on the road for a quarter of an hour less. You guys with me? So whenever you read a problem, a distance rate time problem like that, and you see that it's like different times, not that big of a deal. When you go to fill in the times, one of them's going to be a little less, or you can do a little bit more. You could have said, this was X and this is X plus 1/4. Who cares? The relationship is the same. That's all that math cares about. Okay, maybe. Neato. So how do I fill this in here?
You multiply rate times.
Yeah, this is beautiful. Distance is rate times time. Kick ass. So what do I put there? 45x. And there goes 40x minus
10.
10. Kick ass. 40 times 1/4 is 10. You guys with me? All right, now it should be easy. What equation can you set up now? What have we not used yet? I mean, what is,
We haven't used the mileage, so
yeah, 160 mile apart. So based off of what I've written here, what equation can I write?
45x plus 45x.
Yeah, the distance Anthony went plus the distance Helen went has got to be 160 miles. Let me let that sink in for a second. Anthony went this far, right? Helen goes this far, and then they pass each other. So together they've gone the distance from one town to the other. Together, add these together, they've gone 160 miles. Is that cool? Now what's more difficult?
You still have to figure out what time they met.
That's easy. It's not a problem at all. What's difficult for this is just making this something you can do on your own. So what's the first thing I did?
Drew out.
Yeah, I drew it out. I drew a little picture for myself. I tried to capture the most important information. And then I realized this is a distance rate time problem. I can try to make a little chart, make it a little easier for me to organize. Yes, ma'am.
Wouldn't 45x equal 160 and 40x minus 10 equals 60 because both of them are traveling at the same distance apart? It's not half of them is driving 160 and half of them is driving.
So I didn't make any assumptions about how far either of them went. I have no idea if he went 100 and she went 60. I don't know. All I know is together they went 160. That's the only thing I know about their distances. I know that Anthony went further. What's the only reason I know that? Two things, actually. He left earlier and he's going faster. But I know he went further, so that means he went some more than 80 miles. That's it. That's all I know. Right? That's all I know about his distance. I can't say anything more about his distance beyond that. So I didn't make any assumptions at all about how far either of them went. Anthony went this far. Right? And a non-math person would look at it and say, well, you don't know shit. I'd say, no, I know he went 45x. Screw you. I just got to figure out x is. Right? So he went this far. And Helen went that far. And the only way I can figure out x is if I can set up an equation, and this is the one that ties those together. Right? Whatever Anthony did, plus what Helen did, must be 160 miles.
Oh, okay.
So nowhere did I say, I mean, if they left at the same time, going the same speed, this would be a silly question to ask. Then they would have both went how far?
80.
80 when they meet, right? This is all about by the time they meet. But they didn't. Somebody left later, they're going slower, so they're going to meet closer over there, and I don't have any idea how much closer over there. I don't know. I've got to use algebra to figure it out. Now, this would be the easy step, right? How do you solve this?
170, 85.
You can just add, Jeff. There you go. 170.
2.
And x is 2. What the hell does that mean?
4 p.m. 2 hours.
2 hours.
That means Anthony's been going for 2 hours.
Okay, 90 miles.
She's been going for an hour 45.
Yeah, so she's been going for 1 hour and 45 minutes. So what time do they meet?
4 p.m.
4 p.m. Either way you look at it, 2 hours later than Anthony is 4 p.m. An hour and 45 minutes later than this is still 4 p.m. Of course it is. They have to meet in the middle. Okay, maybe. Okay. But so the most important part of this is not this specific problem. I don't care about Anthony now. I don't know these people. What's important is, do you see how I try to attack the problem? When I first read the problem, I had no idea what the equation was going to look like. I had no idea what the answer was at all. None. So I had to do this for myself. I had to draw it out, kind of summarize the important stuff, make the chart, start filling in what I know. Oh, cool, I know that number. Let me put it in there. I feel better. Got a spot filled in, right? This is what you have to do these problems. Okay, maybe. All right. So I think we did 83 yesterday, right?
Yeah.
What about 84? What's up? Sorry. 84. So this one you can pretty much just draw it out. So the hypotenuse of a right triangle, and of course, which side is the hypotenuse? The biggest one. That's 20. The sum of the lengths of the other two sides is 28. Find the lengths of the other two sides. So Personally, I don't like using more than one variable if I don't have to. You certainly could say that's x and that's y, blah, 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 but you don't have to. Right? If this side is x, what must this side be?
28 minus x.
28 minus x. It's got to be the rest, right? If this was 10, this would have to be 18. 28 minus 10. So together they make 28. So whenever I give you a total number of something, one of them is going to be that total minus x. It's got to be the rest, right? So that's x. This must be 28 minus x. And then, of course, what's going to happen here?
Pythagorean.
Exactly. Pythagorean theorem, right? We had a problem like this, I think, if I remember right. Didn't we? Yeah, I gave you a problem like that. X plus 7 squared, somewhere is in there, right? I think. Maybe I remember now. So yeah, it'd be a squared plus b squared equals c squared. And then you just have to attack that, right? That was a little bit more straightforward than this one was, for sure. Okay, how you guys doing here, all right? Some of you guys look very concerned. So the key to word problems is to not feel like you're supposed to be able to write the equation the minute you've read it once. That is insane. If you think that's true, then I understand why you feel like you don't know math, because you have set the bar above any freaking human ability, right? Draw a picture if it makes sense. Here, I didn't draw towns. I just kind of gave myself some idea of how far they're going. Some visual to look at. It's cool. My brain needs that. Draw a picture if it makes sense. Label stuff on the picture if it makes sense. Is it a geometrical thing? Is it a known equation relationship that I want to use? Right? That's how you got to kind of progress through a word problem. Of course, the next big thing to worry about is, in solving this shouldn't be too hard, but remember you got to FOIL that bad boy out. Yeah, there's other ways to do this.
You could see it. Would you
Okay, that's all I'm doing for that one, by the way.
would
You guys can finish
accept
that out.
if that's what we did?
Yeah, as long as you explain to me what's going on. I will have some problems that there's quicker ways to do it, and I will have some problems where there's not. It won't be based off of one of those. It'll be something gross.
Does he mean continuous way?
No, he means a known Pythagorean triangle. Yeah, like 3, 4, 5. You know, 3, 4, 5, 5, 12, 13, all those kind of things. All right. Okay, what about 85? Did we? I don't know.
86. 85 is not even on the whole.
I like it, so we won't do it. 86. Let's see. Oh, this is, I gave my 110 students, I think, exactly this problem. Just about.
No.
Sort of, not quite, sort of.
Similar. So is that what you do? You look through the review and that's how you make the final?
Sometimes. Hell yeah. Sometimes I just make a problem out of nowhere, but you see enough of these, you're making them based off of something. 3 adjoining garden plots, 1 for each of her kids. So draw it out.
It's not
Each
catching.
plot, huh?
Your thing's not catching if you want to move it over.
Each plot is, thank you, 80 square feet in area. She has 88 feet of fencing material, blah, blah, blah. So if each plot is 80 square feet, she has to make the fencing, she has, what was it, 88 feet of fencing available? And she wants to use all the fencing. She doesn't want some fencing laying around at the end. She wants to use all the fencing. The biggest mistake I see people do on this is they do something related to 2x plus 2y. It's none of that crap here. What's 2x plus 2y? What does that relate to?
Square.
The perimeter of this rectangle, right? But perimeter is not the only thing you have to worry about here, because you need fencing down the middle too. So the very first thing you want to do is identify what variables you want to use. Right? So if this side is y, that's also y.
And 2x. So 2x plus 4.
Oh, well, yeah, so help me out. So are you calling this entire side
X.
x? That's cool, that's what I like it. Let me stop right there for a second. You guys with me? So, creating a picture totally makes sense here. Identify what you don't know. Give it a name. Right? Identify it with a variable. And then I'm going to try to write relationships using those variables. So what algebra does for us is it says, if I ask you how wide is this thing, you're not going to say you don't know. You're going to say it is exactly
Why?
y feet. So then, if I want to write a relationship involving the sides, I totally can. I know exactly how wide it is. It's y feet wide. Right? So, one relationship I could write is, I think you guys are telling me, 4y plus
2x
2x
equals 88.
has to be all the fencing she wants to use. You can do it, Jeff. And then what's another relationship we could write?
1/3 x.
I like it. I like it. So one way to do this maybe a little bit better, just a little. Take the 1/3 out. What's x times y have to be?
Equals 240.
Good. 240 square feet. Right, the total area of the whole thing. Let me stop right there. Let you absorb. Because the reason they're saying 1/3 is if I want to look at the 80, I'd have to use, well, how long is this? 1/3 x. To be honest, I don't even know. Does it say that they're all equally? Yes, they do. All right. I thought maybe she had a favorite kid to give her a little
And it
more
wants the dimensions
room.
for
You're my favorite. You two I don't like.
and it wants the dimensions for each individual square.
Yeah, but they
We'll
did
have
tell
to
us.
come back to that.
Yeah, they did tell us it's the same
So much for
area.
the one
So that's
word.
good. So what can I do from here? What method do I want to use now?
Substitution.
I love it. You can use substitution. It's not. You can't really use elimination easily because this is a product of the x and the y. So how do you do substitution? What do you have to do?
Dividing by y.
All right. So one way to do it is to solve this for x. So to do that, you divide by y, and then you can take this expression
Put it into the
and put it in here for x because you know x is this, so you can put it in there. Cool.
I divided the first one by 2.
I love it. Or you could
Subtract 4y.
solve this for x and plug it in there. And remarkably enough, you'll end up in the same place. Yes, ma'am?
Will you not give us points if we do try that?
No, I will not. Basically because this class is pre-calculus, which uses algebra. This is not... Math 120 is where you could solve a problem almost any way you can think of. And sometimes algebra is the best way. This class specifically teaches us how to use variables to solve problems. So if you get the right answer, but you did so by guessing and checking and not using any variables, you will lose most of the points. Because you didn't do the primary purpose of the class. So I think in that case you need to lose a lot of points. So I want to make that clear right now. You guys with me? So some of these problems you can figure out really easily. I don't mind if you use mathematical concepts like Pythagorean theorem and stuff to kind of shortcut a problem. But guessing and checking, hell no. Because you know sometimes you're going to make the answer 79.142, and I really doubt you're going to guess and check that number. Right? So you're going to have to do that algebra. So completing this out, from the second equation, I know that x is this. So the first equation, I could be smarter about it, 4y plus twice x. And then what's kind of gross about that?
It's a fraction.
There's a fraction, even worse than that, it's a fraction with a variable at the bottom, right? So the first thing you want to do really is...
divide by 2.
Alright, you could divide by 4 actually, right? Because the 240 can handle division by 4. But to kill that y, you just multiply by y. I love it. So one thing you could do is multiply by y. So you get 4y squared plus 480, the y's go away, equals 88y. What kind of problem is this now? How are you going to solve this? You can divide by 4, I know, but what method are you going to use to solve this problem?
Factor.
You got a factor because Why? What part of that tells you have to do that? It's got a higher power on one of the variables. I can't collect all my y stuff together. So I want to make this side
0.
0. Suck that dude over. Divide by 4 so you got smaller numbers. Right. Okay. Some of you guys are looking at me like, what class is this again? So if I divide by 4 and I suck this over, subtract, divide by 4, I get 22. Divide by 4, I get 120. So this one factors really nicely.
Isn't this also a place where you use the negative b over 2a to find the max?
They're not asking for maximum,
So it doesn't matter then on this one?
right? They're asking for,
What dimension?
yeah, just to make that work, what dimensions should they have? So it's not asking to maximize the area or something. Yeah. Cool.
So now you get 2, but you get 2 different y's.
Yeah, so now if I have this equation, how do you factor this?
Y minus 10. 12.
Good. So that wasn't too bad. All right, so y could be 10, or y could be 12. Now you don't stop there, obviously, that's not good. Right? We actually have 2 completely separate situations for how to do this rectangle. Right? These little plots. If y is 10, what's x got to be?
24.
24. So if y is 10 feet, x has got to be 24 feet. If y is 12 feet, x has got to be 20. Okay, maybe. So there's 2 different situations. There's 2 different answers to this question.
Not really.
Why not?
Because you still have to go. She said you don't want any leftover fencing, and when you divide and actually put in the equation, you're going to get like 6 point something for one of the sides. I can't remember which one is on my homework.
No, that's fine. You can still do that. Yeah. You don't have to have any leftover fencing.
So you can measure out to the 6 and 2.
No. You're if I make this 24 feet long, and then I can just put these at equidistant points on there, that's fine. There's nothing wrong with that.
Yeah, but what about the 20? Yeah, I understand that. You did 8. But
No. It's even 20 I can still do. In real life, not everything is a whole number.
I
Right?
understand.
So if I make this 20, and I make this 12, I just have to put 12 there and 12 there, make sure they're equidistant, and I'm golden. Nothing wrong. I don't have any leftover fencing. And it's built into this equation that I don't have any leftover fencing because of this. Any answer I get can't have any leftover fencing because I said I'm going to use all 88 feet. Cool.
But okay.
So don't...
I understand it comes out to 88, but I'm going to grab it.
Go ahead. Don't bring into play any possible human inability to deal with non-integer numbers, right? So Ryan's concern is the fact that if I make this 20 feet long, how long is each of these going to be?
6.6666666.
Yeah. 6 2/3 feet.
But if you multiply that by 12,
And now real quick, hold on. You ready for this? 6 2/3 feet. Stay with me now. I've lost several of you by now. At least you're all looking this way. That's 6 feet and 2/3 feet. Okay, that's amazing. How many inches is a foot? Alright, so that's 6 feet and 3 goes into 12. 4 times 2 is 8. 6 feet 8 inches. I could certainly measure 6 foot 8 inches. Right? Okay. Cool. And it's not surprising that on a problem where I want a certain area for a rectangle, there's more than one answer possible. Yes, sir?
So just for some, if you wanted to maximize it though, would you count this as wrong? It would still come out to, it would come out to be slightly different.
Now, the reason this can't be a maximized problem is because everything is determined. The area is 240 square feet.
Oh yeah, that's right.
The amount of fencing I'm going to use is 88 feet. There's no, I can't change
I
those.
forget about that.
Okay. If I wanted to make this a maximize, they would have said you use 88 feet. How would you set it up so you would make a maximum area? They wouldn't have told you the areas then. Right? That would have been the maximum kind of problem. Yeah.
Sorry, I'm going earlier to column.
This one?
I would have done the 4y squared plus 480, but like set it to 0 there. So how did you get?
Oh, so I divided by 4.
Oh, okay.
Yeah. And then I subtracted 22y over. Yeah. Cool. Anytime you can do that. You don't like it to try to factor it when there's a 4 out front. When there's any number out front that's not a 1, I want to try to divide by it. So here it did divide. That was cool. Yeah.
Just double checking, did the problem say that, she could not have leftover fencing? Because I feel like it kind of implied that, it said how much should she use, like if she wants to use all of it.
Yeah, it didn't really say it, but I'm going to assume that she wants to use all of it. She has 88 feet of fencing that she wants to use. They should have said she's going to use all of it. They didn't, but that's what they meant. Otherwise, how many answers are there here?
So many.
Infinite answer. Here you go, kids. Here's your plot of land. And now I have all this fencing I'm going to use over here. Thanks, Mom. Right? I can't fit it in there. I can't plant 1 carrot. Right? It's not good.
If x equals 20 and y equals 12, then there's 4 difference.
No.
No, there's not.
No.
So let's check it. So if x is 20, so that would be 40 feet of fencing total, right? And if y is 12, that's 1, 2, 3, 4, 48.
I wasn't counting those.
Okay, cool.
We're fine.
Okay. I like it. So, on one level, I love this. You want to make sure that the problem makes sense. I love it. You don't want to just stop at a number and say, ooh, great. So I really love the fact that you guys are trying to see, does this really make sense? Is there something that doesn't make sense about the problem? Like, that kicks ass, because students normally don't do that nearly enough. So I don't want to shut that down. So that's beautiful. I love it. All right. Yeah.
So this is a situation where both answers, where you have like 2 sets of answers, and like both of them work.
And for rectangles, it kind of makes sense because if I wanted to,
I don't know, because usually I've had word problems where like there's one answer, like
oh hell yeah.
you end up with 2, and then the other one doesn't make sense.
But the fact that rectangles, the most simple thing I could do to have the same thing is to actually just turn it around, right? That's kind of a stupid thing, right? But sometimes I have numbers that there's more than one way to break the number up. Like if I want an area of 200 square feet, well that could be 10 times 20, or that could be, you could do it, Jeff, that could be 5 times 40. You kind of with me? So there's multiple ways to achieve that. So in this case, there were 2 exact ways to make this true and this true at the same time. Cool. So she can make it fit in the back corner of her yard. She's got 2 ways to try it out. Cool. Maybe. Okay. So that was the last one there. So let me do this. What I want to do, any other specific questions? 105?
Does the origin mean? Does that mean 0, 0?
Yes. Origin means 0, 0. Where'd it go? There it is. Okay, so. Somebody remind me, what's the equation of a circle centered at the origin with radius r?
X squared
X plus 5.
X squared plus
X squared plus
y squared
Y squared
equals r.
Alright, cool. So that's a circle that hasn't been moved around. How many of you guys did not know that until just now? Feel free to be honest, it's fine. Okay, good. A few more hands popping. This comes really quickly from the fact that a circle is defined to be the collection of all points that are the same distance from some point called the center. Let me say that again. A circle is the collection of all points that are the same distance away from some point we call the center. Does that make sense? Mm-hmm. That's actually the best way to tell somebody what a circle is if they have no idea. Right? You can try to draw it, but mine looks more like Stewie's head than an actual circle. And we call that distance the radius. Now, how far is this I don't know. So how far is it?
X.
X, because it's on the x-axis. It's an excellent choice of variable. How far is this?
Y.
Y. And what's the relationship there? This relationship. Done. Right? Because that point, that argument I just made would work for that point. Would work for that point, right? I can just do the same thing. Make a little right triangle. So the collection of all points that meet that definition is given by that equation. Every point that works in that equation will be on the circle. So real quick, if I had x squared plus y squared equals 25, one possibility would be the point 34. The point 34 would be on this circle y. 3 squared plus 4 squared
Equals 25.
is 25, exactly. So the point 34 is on that circle. The point 43 is on the circle. Right? Trivially, you just switch those, it's the same damn thing. You kind of with me? And of course, all the little numbers in between that I don't want to think about. If x is 2, y is still something disgusting to make it come out to 25, right? So it's going to capture all those points. Okay. If I want to move the circle somewhere, if I don't want it to be centered at 0, 0, if I want this circle to be centered at 1, negative 2,
Be x squared plus 1, or x plus 1 squared times y minus 2 squared
so x,
plus 1.
and I want to shift it 1 over,
Minus 1.
minus 1, I love it,
And
y plus 2, I love it. Now hopefully you all talked about, I'm not sure how you would have talked about vertices for parabolas if you didn't talk a little bit about moving functions around, because if you just pick a parabola up and move it, if you can figure out how much it was moved, you can figure out where the vertex is now, right? So that's exactly that idea of just picking up and moving the circle. Now I know the center is at 1, negative 2. Cool, maybe. So let's look at what this problem says. It says, find an equation on the circle that has center negative 5, negative 1. So circle in general is this. That's a general circle, right? Where h and k are the same h and k you use for parabolas, really. So general, where's the vertex, where's the center? So what can I definitely put in there already that I know for sure?
Plus
The
5.
center. The center is negative 5, negative 1. So I know that this equation to a point is what?
X plus 5, y plus 1.
Yeah, x plus 5, y plus 1. The only thing I don't know yet is the radius. Now what else do they tell me that kind of kicks ass, actually?
The origin.
And it
passes
passes
through the
through the origin.
So let's real quick make sure everybody's kind of with me. They're talking about a circle, and they want to find the equation of a circle, so you immediately write this down for yourself. You're working with this. You got to figure out what you don't know for this. Just like if I say find the equation of a line, you're trying to figure out what m is and what b is to fill that in, right? It's the exact same way. These are the things a circle equation needs to know. They gave me the center. Thank you. Right? So I just put that in. I don't know what the hell the radius is, but they do tell me that it goes through the origin, which is also known as the point.
0, 0.
And why does that kick ass?
Because you can just plug it
Just
in.
plug it in and figure out what the radius is, right? So it goes through, I don't know what that was really. 0, 0. So if I plug it in, this equation has to be true for x equals 0 and y equals 0. Therefore, whatever r I get from plugging it in is the r period. Because it's got to be true for all points. I can figure out what it is using that one point because it's got to be true for all points. So when you plug 0, 0 in, you get?
You get 26.
Yeah, you get 25 plus 1. 26 is r squared. Do you have to square root it? No, because I need to know what r squared is. Yeah, right. So now the equation is x plus 5 squared. We already knew this piece, but now we know r squared is 26. The biggest mistake I see is people do this, but it's r squared. So I don't need that. Now if I said what is the radius, then you would have to do square root of 26. Okay, maybe. Now, just to make this really clear, I don't know if I made this clear the last couple days. Chapter 1 is probably the hardest chapter in this whole book. Not because the level of the stuff, but because it's so freaking dense. Right? You guys know this. If you've looked at all the book, you know there's just so much in chapter 1. It's like everything you've learned so far, and some stuff maybe you haven't, based on your teachers. Right? Okay, so anything else from homework? Yes?
132.
Oh, okay, good. Let's see. So 132. It's about margarita. Not that kind of margarita. This is a person hired by an accountant firm at a salary of $60,000 per year. Listen. 3 years later, her annual salary is increased to $70,500. Did I get it right? 70,500. Yeah.
Said it right.
Assume that her salary increases linearly. This is important. So find an equation that relates her salary to the number of years she's worked for the firm. So that sounds almost impossible, maybe, when you first read it. You're like, I don't know what the hell this is going to be. Well, we know this is a line, so we know the equation is going to have what form?
Y equals mx.
Yeah, so I know it's going to be y equals mx plus b. So all I got to do is figure out n and figure out b. They told us b. I don't know if you realize that. So can you write this information, starting salary of 60,000, can you write that as a point?
Yeah.
T comma money. Right? So the initial is after
1.
no
0.
0 years, because that's her initial. How long has she been there? The minute she's making money, 0 years. At 0 years, she's making $60,000. All right, what's the other thing as a point?
3.
3 years, she's making $70,500. You're not having too many commas in there. That's freaky. We're not doing 3 dimensions yet. Now that makes it a much easier problem. Now part A, all part A really says, and let me make it a little more, let me take this line out of there. These are my variables, not x and y. They're time and salary, right? So this equation really should be, no? What did it just say? S equals MT plus B. But who cares? Y and X are completely arbitrary. They're just letters. I can use whatever freaking letters I want to. Let me make it make sense with what the problem is. So how do I find the slope?
M equals y squared minus y. Or
Here.
Y minus y.
Yeah, y2 minus y1.
There you go. Yeah.
Over
So that's 10,500
x2 minus
over x2 minus x1.
3.
Cool. 3,500. Real quick, how would I know that 3 goes in that evenly? Because you put it in the calculator. No, if you didn't have the calculator, how do you know 3 goes into that? Because these add up to be 6. If you add up all the digits in a number and it adds up to a multiple of 3, 3 goes into it. If it adds up to a multiple of 9, 9 goes into it. Right? These little things people don't know as much anymore. Everybody used to know those. So that is my slope, kick ass. And what's B?
60.
Yeah, 60,000. Right? So S equals 3,500 times time plus where she started.
Cool.
So it was really, to get part A done, that's just part A by the way, to get part A done, you just had to restate the problem. The way they said it made it sound horrible. I go, oh, these are really just points. Find the equation of the line that goes through these points. That should be easy. Should be easy. What about, what's part B say?
Just a slope and intercept.
Oh, all right. What do the slope and S-intercept of her salary represent? So what's that 3,500 really represent?
Her annual increase.
Annual increase. I love it. Right? What are the units on the slope? What's the units of this?
Dollars.
Dollars per
Year.
There you go. It's a rate. It's how much money she can expect to make more each year. It's money per year. And the y-intercept obviously is just her,
Base salary.
yeah, her base salary, where she came in. at. Right? That's not a bad, that's a really good starting salary. Holy crap. What will their salary be after 12 years?
Throw a 12 or
Throw a 12 in. You've got the equation. Now you just throw whatever the hell you want to in. You figure out what it's going to be.
it was a lot.
102.
Yeah, where is this job?
Oh, with a raise like that?
Yeah. Oh yeah, that's what I'm going to pay the... No, yeah, right. The person doing this is going to make $95,000 a year, yes. Okay. Anything else from the homework? Okay, so what I want to do is I want to focus on two things. I want to focus on... Let's take a step away from word problems for a second. I'm feeling you guys might be okay with that. I want to focus on solving a few different kinds of equations. And then we're going to use the rest of the time on word problems. If we have any time left. We'll see. Yeah, we're going to leave a little before 10:30, I think, to do this field trip. Right. So here, I want you guys to do this. So the instructions are the same. Solve. So try these out. Try to make that one come out nice. Let's see if I can make it work. Make sure you guys see that. Stop there. So if you want to, you can compare notes with somebody sitting near you, or you can call me.